Welcome to IGBits. We train, you can learn. We shall continue trigonometry ratios using unit circle concept. We'll be finding two unique triangles where how we are going to find out a length of each side and identification of angles with which you can started measuring values of each trigonometry ratios. So let's get started. Now IGBits is available on YouTube for everyone to access our already completed sessions and also keep uploading upcoming sessions. Please do visit us at our YouTube channel and also help extend your support to share our channel information to your friends. I'm sure you all know that how support is really help a one in need, isn't it? A true friend is someone who assists when one is in need. Thank you all so far. Whatever the support that you are doing, please do continue to support us to grow. Thank you. So let's have a quick review of uh, how coordinates on Cartesian plane and the coordinate points can be represented on the Cartesian plane. Okay, this is one of the prerequisite to understand the following topic. Let's say we have the Cartesian plane. For our sake of understanding, I am divided into some units so that I can navigate my distance from the origin. Origin is nothing but a center point, origin or origin, okay, which is a 0 0. The representation of any point on coordinates is x comma y. X coordinate comma y coordinate is known as coordinate pairs, is coordinates. Okay, point means x comma y in two-dimensional Cartesian plane. Okay, so now let's say this is positive x axis, right, towards your right direction, towards to our positive y direction. Opposite to positive x, there would be a negative x, right? This is called a negative x in negative direction, and then downward direction opposite to positive y would be your negative y. So that is how your Cartesian plane is divided into four parts. Okay, next one, you start from positive x rotating anti-clockwise direction to touch the plus y and then back to minus x, back to plus minus y, and then reach back to plus x is nothing but one revolution. So in degrees, you start from 0 degree and then you are completing 360 degree, right, is nothing but one revolution, right? So that's one thing that you have to understand. Next one is coordinates. How do you represent coordinates on the Cartesian plane? So let's say what we are representing here, 1 plus 1, is it? 1 plus 1 means this is x point, this is y point. So if I can denote that portion, so x direction, what do you say? X comma y. This is my point. When I say 1 1, first of all, x positive, y positive should be this coordinate. This quadrant is first quadrant where x is positive and y is also positive, and hence this should be first one. So from origin you travel towards to the x direction 1 unit. From there you travel towards the y direction, upward direction 1 unit. So that junction point is nothing but your coordinate points 1 1. Okay, when you wanted to represent point 1 1 on Cartesian plane, I can recognize by signature like signs. Plus plus means first quadrant where x is positive and then y is positive, and then I just travel from origin, first travel towards the x direction, from there to y direction. That is where I can mark my point. Let's take a second point, minus 1 plus 1, minus x and plus 1. Minus x and plus 1 would be this quadrant, second quadrant. So I have to travel from origin towards the x minus x direction is 1 unit. From there, I have to travel upward direction 1 unit. That is what point means, 1, 1, my Cartesian. So this would be your -1 and 1 point. Okay. Similarly, you see this one, 1 minus 1, x positive and y negative. X positive and this y negative is this. That means like a third quadrant. In third quadrant, how do you say? I have to travel positive x is one direction, and then y direction negative y is a downwards, which is a one more unit. So my point would be this one, which is 1 minus 1. Okay. If at all I can use minus minus, then this is the third quadrant. So I'm sorry, this is the fourth one. This is the third one. In the third quadrant, what I see minus 1, but that means this is a point. I'm equidistant from x and y and the negative. Okay, let's take this one, 3 minus 3 for instance. What happens, like x is 3 and y is minus 3, right? Minus y. So x positive and then y negative. X positive, y negative would be your fourth quadrant. So traveling towards to this direction for 3 units. From there, you travel towards the down direction, y direction. This, so that means like you're reaching the point here, which is positive 3 and a negative 3, right? So in quadrant 1, first quadrant, my coordinates are plus plus x and y. Okay. In the second quadrant, my coordinates are minus x plus y. My 3q, my coordinates are minus and minus. Fourth quadrant, my coordinates are minus plus 1 minus 1. So x positive and negative. This is how you can remember. If you see, I placed a unit circle on Cartesian plane. Unit circle means the radius of circle is equal to 1 unit, right? Let's try, find out a coordinates for this unit circle. So let me pick my, pen to represent values. We know that this is a positive x, this is negative x, this is positive y, this is negative y. Okay. When I say this is 1 unit, what this means, like this is a radius. This is also radius from here to here, right? This is also 1. And then this also same. So let me pick a colored, different color. Look at this one. This is also 1 because this is 0, 0. And you can see this unit also, because this is also radius 1, this is also radius 1, this is 1, this one. So if I see this point, and then origin, we know origin is how much? 0, 0. So my x-axis I'm traveling to 1, but y is there is no change. This would be, what is the point? This point would be 1, 0, right? X is 1 and y is 0. If I say this point, so what happens here? I mean, there is no change in x, so this is 0 x, y is 1, right? Because my radius 1. In this, if you look at how do you represent this one, I travel from origin to negative x 1 unit, so minus 1. Is there any change in y direction? No. That means this point is minus 1, 0. Look at this point now. So I am in y-axis, so x coordinate is 0, but y coordinate is 1, which is a negative direction, so minus 1. This is how you can represent. So how the unit circle should be. So on the unit circle, what we were saying is, if the radius is 1 unit, making an angle with x-axis is theta, then it forms a right angle triangle and then identify what is the value of an angle. Let's take a unit circle. I know this is an x-axis, right? Positive x and negative x. Let me draw my y-axis and then denoting positive y and negative y, right? What I'm trying to do, say this is a quadrant one, first quadrant between positive x and positive y, right? The point that I'm marking on circle in first quadrant, right? That's what I was trying to, illustrate here. And then positive y, negative x, right? This is a second quadrant and third quadrant, fourth quadrant. So my Cartesian plane is divided into four quadrants, and then I denoted my axis names, and then coordinate points can be represented by making sure the sign is known to you. I'm started actually, starting with a 0 on x-axis. Start with a 0 degree in anti-clockwise direction. Like I said, circle means 360 degrees. We'll see like you split circle into some equal parts and then put some angle in it and all for understanding. Okay. So we know this is 0 degree and then circle is divided into four, and then x and y are the perpendicular to each other. So y is, I know, unit circle touches at y point and circumference. This is called 90 degrees point, right? Because the angle between x and y is 90 degrees. Similarly, x and minus x, the angle, right? This angle is 180 degree, right? So 300, 270 on y-axis downward and 360. So now we are clear. So we have a 490 splits. Each quadrant occupies 90-degree space on a circle of 360 degrees. So equally divided. Clear? Let's say this is my radius, and then I'm drawing a line downwards from point 2 onto x-axis. So if you could see this, it forms a right angle triangle. Okay, and then length of this would be sine theta. You know how? This would be the cos theta. I think we discussed this point already, but if at all you need to recap back again. So if you say this is a theta, right, and then this is 1, then what would be my sine theta? Sine theta equal opposite by hypotenuse, right? Opposite means this one, and then hypotenuse is 1. So opposite side is nothing but your sine theta. That's why sine theta. Because, right? Similarly, cos theta can also be represented. Cos theta means adjacent by 1. So adjacent is equal to cos theta. That's why this is a cos theta. So cos theta and sine theta. This also sine theta because both are parallels. But this is how you can note it. So if the x length is cos theta and then y is also length of sine theta, then how do you represent this point? This is x comma y is nothing but sine theta, right? Sine theta, no, this is a cos theta x direction, right? First, then sine theta. X theta comma sine theta would be your point P. Agree? That's what I'm representing. So now, what would be the degrees here? So I'm saying like a 45 degrees angle. This angle would be, in our case, is 45 degrees is what is taken. Because if you look at this, the quarter circle is divided into two equal parts by this line. That's why I can see 0 and 90, the middle number is 45. This would be 45 degrees. Okay. Similarly, in the second quadrant, if I say this is 90, this is 180, the midpoint is 135, right? 90 plus 45, this angle. Similarly, in the third quadrant, multiple of 45, right? That's a 225, and then 3 and 5. So the midpoint between the 360 and then 270 is 315, right? If this is 1 by root 2, 1 by root 2, right? Because sine 45 or cos 45, both lengths are 1 by root 2. This is 1, this is 1 by root 2, this is 1 by root 2. Then this point is xy, 1 by root 2, 1 by root 2. And then this is a positive coordinate, first quadrant where x and y are positives, right? Plus plus. Similarly here, what happens? This is again a 45 degrees angle, but opposite direction. And hence here your points would be 1 by root 2 and 1 by root 2, but the sign x negative and then y positive. This is how you can say. In the third quadrant, minus x, so minus 1 by root 2, and then minus 1 by root 2 y also, because minus x minus y, is it? This is what it is. And then whereas here, they should be the same, right? Here plus x and minus y, and hence the values would be plus 1 by root 2 minus 1 by root 2 points, because this is a multiple of 45's. If you look at this unit circle, what we have seen is that this is a 45 degrees, and this is a radius of the circle of 1 unit, right? Because unit circle means radius is 1 unit, which we discussed. So now the question here is, if this is 45 degrees, what would be this angle? If you clearly observe, let's say this is origin O, this is A, and this is B, right? And then the angle A here is 90 degrees. In the right angle triangle, one is 90 and the one is 45, right? So sum of the angles in the triangle is 180, right? So if this is already 90, this is 45, then the remaining is only 45, this much. If now you see two angles are same, must be the two sides also the same, and hence this is a isosceles triangle. Now we have to figure out what is the length of 0, I mean this x-axis 0a and then ab. I know this is a cos theta and sin theta, and then if we would know the values, this point would be cos 45 degrees and sin 45 degrees, right? If I know the values, I can represent directly what my number would be. So probably this is 1 by root 2 and 1 by root 2. Let's see how these values can be, found. All right, so we know this is a right angle triangle, and then 90, 45, 45, right? So this is isosceles right angle triangle that we know. And then we also talk about AC is the radius of the unit circle, which is of 1 unit. Correct, no? 1 unit. So let me put the value 1 unit. So what I would do here is, if I would construct a square of length 1 unit, okay, as the AC as a side, then the what I can form is a square, right? Square units. So this square, so if each side is 1, then area of the square is 1 into 1 is nothing but 1, right? Similarly, for other two sides also, let me construct a square. BC is a length of a triangle, but I'm trying to extend this by for constructing a square. So, right. So I don't know how much length by BC, how much length by AB, but I would say these two are actually have two squares of length BC and AC respectively. As per my Pythagoras law, area of this square should be a sum of area of this and area of this, right? So what I'm saying is like 1 equal to 1 by 2 plus 1 by 2. Right? That is what I am saying. Because formula, what it says, hypotenuse square equal to side square plus side square. Means like this is a bigger square, these are the small squares. That is how I'm representing. So if my area is F, then what would be my BC? Right? So my BC would be 1 by root 2, because we know area of square, right, equal to A square. If A is a side, means A into A. So if I want to calculate A, then root over area, right, which is nothing but root A square. That is how I'm calculating. Here also, my area is F, then my side would be 1 by root 2. So if you say this one, if I look at this now, hypotenuse is 1, and then opposite is 1 by root 2, and then adjacent is 1 by root 2, right? So my sine theta and my cos theta, how much here in this? My sine theta, sine 45 degrees, if at all this is 45 degrees, right? So my sine 45 equal to opposite by hypotenuse is nothing but 1 by root 2. Similarly, my cos theta. What is my cos theta? My cos theta is like adjacent by hypotenuse. Adjacent is how much? 1 by root 2. So 1 by root 2, right, by 1. And hence sine 45 and cos 45 points are how much? 1 by root 2, 1 by root 2, which is what I noted on my unit circle in the previous slide. So my takeaway is 45 degrees right angle triangle, and then my hypotenuse is 1 because of my unit circle, then my opposite is 1 by root 2, my adjacent is 1 by root 2. These things we have to remember. The reason for saying that, we have a trigonometric ratios, right? Sine 45 and cos 45 and tan 45. Sine 45 means like what is that? Opposite, BC by AC. So BC is 1 by root 2 by 1, and hence 1 by root 2. Similarly, cos 45 is AB by AC, which is also 1 by root 2. Sine 45 means how much? I mean tan 45 means sine 45 by cot 45, cos 45. So 1 by root 2 by 1 by root 2 is nothing but 1, right? Other way, what you can say, opposite side, right? Opposite side BC by adjacent is AB, which is also 1 by root 2 by 1 by root 2, which is also, you can cross them both, so you get 1, right? So cot 45 means how much? Opposite, reciprocal to tan 45, right? Which is nothing but 1. Similarly, secant 45 means 1 by cos 45. Agree? So cos 45 is 1 by root 2. So reciprocal is root 2. So on the same way, cos 45. Cosecant 45 means 1 by sine 45. 1 by sine 45 means similarly 1 by root 2. Reciprocal of 1 by root 2 is nothing but root 2. This is how we can calculate sine, cos, tan, cos, cot, secant, cosecant for this isosceles right angle triangle of angle 90, 45, 45. When you say isosceles right angle means like 90, isosceles means like two angles should be same. So 45, 45 is a shade. So let me illustrate one more, triangle of 30, 60 and 90 degrees, how the values of that right angle triangle. Okay, this is the unit circle of radius 1 unit, and this is a 30 degrees angle making with x-axis, right? If I draw a perpendicular here, and when I say perpendicular, this is like a 90 degrees within a right angle triangle. If this is 30 and the 90, what would be this one? 30 plus 90 plus x equal to 180, and hence x value would be 60 degrees. So this is 60, right? So what I will do, I will extend this point to down, and then I will join two lines like this. So now we know this is 30 degrees, right? This is right angle triangle, right? This is also 90. If 30, 90, and in the downward triangle, the angle here should be 60. Now you see all the 3 points. This is 360, this is 60, this is 60. So when we see a triangle forming with each angle 60 is nothing but equilateral triangle, and hence we know this is 1, this is 1. What would be this value? This is also 1 unit, right? So you have to take this as a reference, and then if you look at this, the length, the points joined by 30 degrees point and 330 degrees point, right? This line, this particular line is divided by the x-axis, right, equally, right, bisecting, and hence what I can say, the length of this small unit, right, when total is f, then what would be the small portion? The small portion would be, let me put this way. This is one, this is one, this is one, and I'm not this one. So this total is one, and then this divided by f. So f and f, agree? Total one unit. This is 60, this is 60, and then we know this is also 60, right? So now what is a triangle that we got it? Like this, right? If this is 30 degrees, obviously this is 60, and then this is 90. What we are saying, this is 1, this is f. Do you know what this value would be? As per Pythagoras law, ABC, right? If you know A, if you want to know AB, AB equal to AC square, hypotenuse square minus BC square. So 1 square minus 1 by 2 whole square, right? 1 by 1 by 4 is nothing but 3 by 4, and hence AB equal to root 3 by 2. This value would be root 3 by 2. So these two triangles are important for us to remember. So finally what we found, 30 degrees, 90, and then 60, and this is a hypotenuse 1, and opposite is like 1 by 2, then the base is root 3 by 2 is what we found. Okay, this is the one more thing that we have to remember. So let these are the two triangles which we talk, right? So 45, 45, 90 is one triangle, 45 degrees, 90 degrees, and then second one would be 30, 60, 90. Okay, these two triangles, and these are the values. So make use of these things. You can find out the ratios, trigonometric ratios, the values of all the trigonometric ratios at a given angles. Thanks for watching. Please like, share, subscribe, click on bell icon, and leave the comments. Thank you all. So we reached the end of the session. See you tomorrow with a new topic.